For this problem, we need to switch and use our pi circle instead of the ear circle. First thing we need to determine is the wattage. So I have been given 11.92 volts times 48.6 amps. And using my pie chart and the value of my thumb, I know I need to multiply. 6 times 2 is 12, carry a 1. 54 plus 1 is 55. 5, how about 6 times 1 is 6 plus 5 is 11. And 6 times 1 is 6 plus 1 is 7. 0 to hold my place. 8 times 2 is 16, carry that 1. 8 times 9 is 72 plus 1 is 73. 8 times 1 is 8 plus 7 is 15. Carry a 1. 8 times 1 is 8 plus 1 is 9. Now I'm going to add 2 zeros to hold my place. 4 times 2 is 8. 4 times 9 is 36. Put the 6 down. Carry that 3. 4 times 1 is 4 plus 3 is 7. And then I have the 4 times 1. Now I'm going to add those together. I'll have 2, 11, carry a 1, 13, carry a 1, 19, carry a 1, 17, carry a 1, 5, and place my decimal. I have 3 places behind the decimal, so I need to move over 3 spots. And my answer is 312, excuse me, let me erase that. 312 watts. Now, we're going to use this information on wattage to determine our horsepower. Please proceed to the next screen to determine the horsepower. Just a reminder that there are 746 watts in every horsepower. So to determine the horsepower for our problem, we're going to take our wattage of 579.312, divide that by 746. I don't have a decimal in my divisor, so I don't need to move them, so I'm just going to move my decimal straight up. Now, I need to determine how many times 746 will go into 5,793. And I'm going to say 7, and 7 times 746, and I just did this on a piece of scrap paper on the side, is 5,222. Then I subtract and bring down the next digit. And that's going to be 7 again. I can't get much closer. Then subtract 0, that would be 9. Make that a 6. 10 minus 2 is 8. 6 minus 2 is 4. Bring down the next digit. And remember, we're rounding to the 10th, so we really could be done, but let's just finish this out since we've got it started. Times 6. And when I did that on the side, I get 4,476. Subtract 414. And I could keep going. I would add a 0 and bring it down. But I'm going to stop there because our engine is working at 0.78 horsepower, or if we are rounding to the tenths, 0.8 horsepower would be an acceptable answer. Please continue on to the next problem. Here we have the brake light on a car is connected to a 12-volt battery. If the resulting current is 0.4 amps, what is the resistance of the brake light? I want you to determine, whether you're going to use ear or pi. So decide that, set up your formula, and solve the problem for the missing unit. In this case, we're looking for resistance. When you're ready, restart the video and check your answer. With the information given, I've determined that I need to use ear. I have 12 volts, 0.4 amps, and I'm looking for resistance. The only formula that has resistance in it is ear. So resistance equals voltage divided by amperage, replacing with the values, E equals 12 divided by 0.4. I'm going to come over to the side, do my math. And remember, decimals are always at the end of the whole numbers, so I need to move this one place to make my divisor a whole number. Same thing here, and then move it straight up. And 4 will go into 12 3 times. But I need to go all the way until I hit that decimal. When I subtract, I get 0, drop the next digit down. 4 goes into 0 0 times, so my answer is going to be 30 ohms of resistance for this brake light. Continue on to the next problem. Once again, we have another story problem. There is a 0.5 amp current passing through a light bulb. The voltage across the bulb is 4 volts. What is the bulb's resistance? Once again, determine whether to use pi or ear and know why you selected that particular formula, and continue on when you're ready to check your answer. Here again, we're looking for resistance, so I'm going to use ear, so I have R equals E divided by I, and in this case, I'm going to have R equals 4 volts divided by half an amp. Setting that up, 0.5 into 4, move over one spot, and up. 40 divided by 5 is 8. This light bulb has a resistance of 8 ohms. Hope you got that correct. Proceed on to the next problem. As you can see, there are 2 parts to this problem. So if an electric motor operates on 240 volts and 7.5 amps, how many watts would you use? Then, once you determine the wattage, determine the horsepower equivalent. Pause the video, select the appropriate formulas, solve, and then restart the video to check your answers. We will need to use pi. I'm looking for wattage, so P, wattage, equals current times voltage. We're given the current of 7.5 amps times 240 volts. Off on the side, I'm going to do 240 times 7.5. 5 times 0 is 0. 5 times 4 is 20. Carry the 2. 5 times 2, 10. Plus 2 is 12. 0 down to hold my spot. 7 times 0 is 0. 7 times 8 is 28. Carry the 2. 7 times 4 is 14. Plus 2 is 16. Then I will add up those 2 products. 8 plus 2 is 10. Carry a 1. 6, 7, 8. And then place my decimal. I have 1 spot after the decimal, so I come over 1. So this has 1,800 watts. Continue on to the next screen to determine the horsepower. Once again, our constant, 1 horsepower, is 746 watts. So I'm going to divide 746 into my 1,800 watts to determine my equivalent. 746 into 1,800 will be twice. 2 times 6, 12, carry a 1, 8, 9, 1490, then subtract 1492. Excuse me. Columbus sailed the ocean blue, by the way. 7, 10, 8, 308 and bring down the next digit. And to me that looks like 4. I'm going to go off to the side and multiply and make sure. It is 4, and 4 times 746 is 2,984. And I'm going to subtract. That makes that a 7, a 10, 6, 2, 9, 1. 17 minus 9 is 960. When I bring down the next digit, and that will go in 1 time, 746. And that's far enough since I'm rounding off to the tenths place. So this problem, the answer is 2.4 horsepower is the equivalent. Continue on to the next problem. We're almost done. This is our last example problem. How much electrical power is going into a starter motor if the system draws 480 amps at 12.5 volts? And then what is the horsepower equivalent? Once again, 2 parts. We're looking for power or wattage, so we'll use pi. Continue on to the next screen once you have solved the problem to check your answer. The first part is to determine the wattage, so we'll have power equals our amperage times our voltage. Replacing with the numbers, power equals 480 times 12.5. I'm going to do that off on the side. 480 times 12.5. 5 times 0. 5 times 8 is 40. Carry the 4. 24. A 0 down to hold the place. 2 times 0 is 0. 2 times 8 is 16. Carry a 1. 8, 9. And then I'm going to put 2 zeros down to hold my spot. And then 1 times 0, 1 times 8, and 1 times 4. Then I'm going to add those products. 0 plus 0 plus 0. 4 plus 6 is 10. Carry a 1. That's 20. And 6. And I have 1 spot behind the decimal, so 1 spot behind the decimal. This has 6,000 watts of power. Continue on to the next screen to see what the horsepower equivalent is. Once again, horsepower is wattage divided by 746. Substituting my values, horsepower is going to equal 6,000 watts divided by 746. Doing my math, 746 divided into 6,000. I'm going to add a couple spots so I can round. And 746 into 6,000, I'm going to say 8 times. And 8 times 746, I've done this off on the side, is 5,968. And I'm going to subtract 5, 9, 9, 10. 2, 9 minus 6 is 3, 9 minus 9, and 5 minus 5 are nothing. And so I drop the next digit. 746 won't fit into 320, so I put a 0 to hold my place. And drop the next 0. So 746 should go in here 4 times. 4 times 6 is 24, carry a 2, that's 16, 18, carry a 1. 4 times 7 is 28, plus 1 is 29, and we can subtract that off. 10 minus 4 is 6, 9 minus 8 is 1. That should be a 2. And I don't need to continue on because I'm only rounding to the tenths place. This will be 8.0 horsepower or simply 8 horsepower when I do my rounding. I hope you feel ready for the quiz or the test. If not, please talk to Mr. Kimball, Mr. D, or to me so we can clear up any problems you may have. Good luck, and don't forget to ask those questions if you're stuck.